Aloha, Rich Alverson. This is ITS128, and today's October 12th. Let me share my screen. Number two. Okay, got a new setup here. Um, 128. I think we're behind because of election day. Uh, okay. Now, why is this so? Can I make this? All right. I hope you can see that. We are in November 12th. Lists. Yeah, lists are pretty important. So I'm just going to go with lists. Chapter 8. I'm going to start with chapter 8. And so let me open up the textbook. And here we are. If I could do something here. This is number 2. Is the okay. Can I do this? That looks better as far as I'm concerned. All right, so let's hope that worked out. See where we are. And of course, it's not telling me how far I got because the internet connection is slow, I guess. But let me just go to. I think we finished strings. Maybe we didn't. Yeah, some check marks there. Yeah, okay. So splitting and joining. Let's go back here. And okay, so splitting and joining. Yeah, that's didn't do anything here. I guess I'm gonna do this splitting and joining thing because it's pretty important. Basically, it's how to take a string and turn it into a list. Wait, we covered lists yet? I thought we were going to cover lists. Hmm. Okay, well, what a great transition into lists. Let's go back and do splitting and joining. Okay, so splitting and joining is taking a list, which is, several things in order and making that into a single thing. And the single thing is a string. So when you do that, uh, you often want to have some sort of separator character in between the uh, the items in the list, um, the elements of the list, and so that's the separator. And so split takes a string and turns it into a list, and joining a list takes a list and turns it back into a string. So for example, this string, if we split it on the hashtag, that's a separator, it turns into a list with 3 items, the each of these things here. So yeah, like that. Okay, so that's splitting. And then and you use this all the time. You use this all the time. And so that's splitting. Okay, so let's look at this one. Okay, so the default is a space. So it would be I and then scream semicolon to you scream, we all scream. So it's not that. We're gonna split it. Okay, so we're gonna split it, and it's gonna be um I and then scream. Oh, it's this one. It was I and then scream semicolon and then you and then scream semicolon and then we and then all. Okay, so it's this last one. So that yeah, that's right. Right. Okay, so that and joining is going backwards, where you have a list, and here there's an explicit there's an explicit list here. It's got two elements in it, two strings. And the first element is a string Bill Gates, and the second element is a string Microsoft. And we're going to join on a on an at sign. And so it's going to be Bill Gates at Microsoft. It's going to be this is what it's going to be end up when it's done. See? So this this is an expression that evaluates to this string right here. So this is going to be equal to this when it's done. Okay, so that's easy. That's joining. And we use this all the time too. So let's try to do a challenge here real quick. Okay. Okay. So type the program's output. Um, we have a string, and we split it on the default, which is a space. And so we get these tokens, and this is going to be a list, and it's called item tokens, and there's three elements in the list. And so the 0th element is book, and the second element, item index number 1, is quantity and price. So it looks like what they're saying is this is the item, and this is the quantity, and this is the price. And so then we want to print this out. Okay, so first we're going to print the item, which is book, space, stock, colon, space, and then the quantity, which was 14. And then we're going to go enter because it's the end. And then we're going to do price, colon, space, whatever that one, which was 20. Enter. And so that is what that is. Okay, you can do the next one. Okay, here we're joining something right back. We're joining something back together again. And so I'll do number 2, okay, real quick. Okay, okay, we've got two strings. This string, and we've got this is a value right from input, and we're going to split this string into tokens using the default separator, which was a space, and assigned color list to that um, result. And then we're going to replace the third element with with new value. Interesting. Okay, so first let's do the first thing. First, let's split all colors into tokens using the default separator and assigned color list. Copy. All right, so color list, this equals um, all colors dot split parentheses nothing because it's the default is a space. Okay, and then replace the third element, all colors, and we can do this because lists are mutable. All colors, uh, um, the third element, which is the 2, equals new value. All right. I wonder if this is right. Let's see. Uh-oh. Let's see. What did I do wrong? Oh, didn't produce output. Oh, do I got to put it back? Well, maybe I have to join them back up again. Color list doesn't say that, does it? Color list equals uh, that dot all colors. Is this right? I know join. No, how do we? It's different in every language. Where's the join? Join is uh, yeah. Is this oh, this is the default is a nothing. Okay, well that's interesting. Okay. Dot join and okay, it's dot join. Yes. Oh. Hmm? Yeah. Key okay, all do I put all colors here? So so I don't have to I don't think I have to put this here. So let me just see if this is right. I'm getting a oops, no output. Um what am I doing wrong? The color let's read what it says. The colors assign the list and return by calling all colors split without an argument. Hmm. The input is that, and then it's supposed to replace the third one with purple. So the input is that, new value is that, and then the we create color list when I'm it's just some syntax thing I'm doing wrong. Okay, let's just go back up here and let's join and color list is mhm, URL split into tokens. Hmm. Okay, I'm gonna do this. Copy this, and I'm gonna go up to. You know what I'm doing? Okay. Anyway, I'm gonna go over to here. Go to here, and I'm gonna paste my program there. And I'm gonna go back. I should have opened up a new window. Okay, I'm gonna um, open this up, and I'm gonna go back to strings, and I'm gonna go back to this one, back to down here, which is where I what? Oh, oh, I don't have my thing in. Can I do this? Oops, can I do this? Is it there? Oh, I guess I left my. Um, all right. Let's. Sorry, I'm not. It doesn't look like I'm very organized today, does it? Okay, so let me go back to here, and I wanna use this window here to write my code. Okay, and so I'm gonna start. Oh, so I'm gonna go back to here. This is my window to start my code. Oh, what did I do? Okay, and this is the okay. So I said that this is, huh, okay, string all beverages, this string and this integer is read from input. Perform the following test. Split this into tokens using that. Okay, so that's the first thing I'm going to do. Beverage list equals all beverages um, split parentheses quote semicolon quote n. Okay, and then oh, then I'm going to output print Ben's beverage colon close colon no, colon. I can do it this way, and then print beverage list uh, this Ben's choice. Okay, that's my answer. Let's see if that's right. And it's right. Hmm. Wonder what I was doing wrong before. Oh well. Oh well. It's okay. Let's do the third one then. All right. Let's say this is read from input. Join the strings to create a single string with this with the semi with a separator of comma, yeah, and assign this the result. Hmm. Oh, I see what to do here. Okay, T is list. Okay, so now I have T is list, and I want to do beverage choices equals um, using a comma, join Tia's list. Is this all it is? No. Okay. Oh, oh, really? Well, can I do this? Oh, look, there's a little space there. Hmm. All right, I'll put a little space. Yeah. Okay, very good. Okay, so anyway, that's going from lists to strings back to lists again. So now let's start doing lists here. Hmm, okay, someday maybe. Okay, so list basics, a list is a um, two term. Okay, a list is a they call a list a container. A container is an object that groups related um, objects together. A list is a mutable container. Okay, so the whole list is a container, and it contains objects, and there's an order to them, and you can change elements. You can change the objects in the list. So in other words, you can, pass a list to a a method, and the method can change elements in the list and then pass it back or not pass it back. It just changes the elements in the list, and then after you return, then the elements are changed. Whereas um, if it's not mutable, like a string is not mutable, so you can't change characters in a string. You have to make a new string. If you want to do that, you have to make a new string. All right, so anyway, so this explains that. Hmm, well, that's interesting. There's a list can also be created with a built-in function called list, and you put a single iterable object as the argument, and it'll return something that looks like that. Hmm. The index is an integer, which refers to a specific position of a list in the sequence of elements. Start counting at 0. So you can, and these are some common list operations. This is how you refer to an element in a list by its index. Here you can get a new list, create a new list based on a subset of elements, and you can make a new list by taking two existing lists and concatenating them together into a new list. And this is how you can change an element in a list. And this is how you can delete an element in a list. All right, so let's do some. Which statement deletes the third element in the list? It'd be this one, I guess. All right, so enter the output. Hmm. Okay. Hmm. Okay, so this is a good example which shows how you can start with a list, make a copy of the entire list because you want to mess with it, but you want the original list to stay the same. So let's see if I'm right. Okay, so the first we create a new instance of a list called my teams, and this is what it looks like. And then we create a copy um, called your teams, and it's a copy. It's not the same. And then we change my teams, the second element, to Lakers instead of, okay, so that's gonna make this be Lakers, but that stays Heat. And then we're gonna print my teams, and it prints with Lakers, and then when it prints your teams, it's still what it was. All right, so I guess when we print a list, it prints out just like a list prints out. Uh, oh, okay. So now we say we have user values, and we take the 6 and add 1 to it. And we take the 6 and add 1 to it and put that back in the 6, or put that back into the second element. And then we take the 0th element, which is the first element here, and we add 2 to it, and we store that back in as the 0th element. And then we print it out. So the 0th element changed to a 4, and the next element changed to it was 6 plus 1 makes 7. And then the last one is still 8. Nothing happened to the last one. Okay. Yeah. All right, let's try the last one. All right. Well, you can do this one. All right, we start out with 1, 6, and 7. We start out with that, okay? And then we take this one and we store it into the first one. So I'm going to copy this and I'm going to store it here. Okay, there. I executed this line. And now I'm going to execute this line, which is going to take this one, and it's going to store it into the 0th element, which is this one. Okay, is that right? Yeah. All right. Let's do this one. Okay, so we read in a value for m, and then we define a new list, which is empty. And then we read in something and we split it, and then we store. We append. Yes, appending means we're just going to add them in. We're going to shove them in from the back. We're going to shove in these elements, which will be converted into integers. We're going to shove them into list data, and assume m is always between 1 and 7. Where's the 7? Where does the 7 come in? I don't see m anyplace. Hmm. Hmm. Oh, m is read as input. Oh, yeah, m is read as input. Then 7 integers are read. Output list item. Okay. Output list item followed by the mth element of the list. Okay. Okay. Got it. Okay. So now I'm gonna output. Hmm, hmm. Do I gotta press start or something? Something silly like that. All right. Print. Print. List item colon, close the quote, comma, the mth element of the list, which would be list data, of something. And what is the something? It is, let's see, 99 is supposed to be the 6th element. So 0, 1, 2, 3, 4, 5. And we want the 6th element. Well, I guess it's m minus 1. Because if it's the 6th element is element number 5. 0, 1, 2, 3, 4, 5, and then that's 90. All right. So I think that's the answer. Oh, good. It's the answer. All right, let's try the hardest one. Hmm. Down here. Okay. So 4 strings are read from input and stored in here. Um, list. Okay, so these names are read in, and that's going to be in here. And then we're supposed to assign with a copy of the elements, starting with index 1 and ending but not including it. So 1 to 3. So I'm going to say assign names equals list names list 1:3. So that's going to be in this case Ben and Rob. Is that it? Hmm. Hmm. Is that it? Let's see if that's it. What? Okay. No. Yes, I did. So what? What do you want to make of it? I mean, it didn't know. All right. So E assigned. I see. So yeah, it said, did I mean that? No, actually, the other thing. I meant my other thing to be that. So, all right, let's see if this is it. All right. Interesting. Okay. All right. So now we're going to get into list methods. So so this is how you add an element to a list. You just do append and it sticks it on the end of the list. And then this is how you extend a list. Okay, let's say you want to add another list to the end of a list. This is how you do that. You use extend instead of append. You use extend, and the argument here has to be a list. Here the argument is an element. Here the argument is another list. And then if you want to insert something before a position, if you want to insert an item or insert an element before a particular element, actually replacing, or another way of looking at this is if you want to insert an item as item number I, then this is how you do it. You say, I want to insert, this is my list, and I want to instead insert 1.7 as my item at index 1. So what happens is everything from item 2 and above, everything from 1 and above gets pushed up 1, and then it opens up a spot, and that's why this. All right, so and then you can remove elements this way. This will remove the first item in the list with this value, so it actually goes along and finds it, and then it takes it away. So if there's more than one, it'll only take away the first one. This removes the last item in the list and gives it to you. So this is gonna This pop is going to take the last item in the list, the highest indexed number list. The last one you put onto the list, presumably, is the first one that pops off. It's like a stack. And then, but the you might not want the last element. You might want some other element that's not the last element, and there you can put in an argument of which one you want. And then it'll shift all the items. So if you pop off the first item in the list, in other words, if you treat it like a list, yes, yes, yeah.
Our favorite student.
Oh yeah, no, I know. My only student, yeah.
Our favorite student.
Okay, I'll see you.
When are you going?
It's next week. Tay will be taking the class next week. The other guy is going to be here next week. But I'm going to be around for a while. Are you going home now? Okay, all right. Well, we'll talk. We'll talk. I'll be around next week. But I'm going to be here with Tay next week. All right. All right. Very good. So remove. Okay. So if you pop off, for example, the zeroth element, in other words. Presumably, if you're adding to the list by using the append, then the very first element that you put on the list is going to be the zeroth element, and the way you pop off that zeroth element is this way, and that's treating the list like a first in first out, as opposed to a last in first out, a queue. So you treat it like use it like a queue, which is first in first out, or treat it like a stack, which is last in first out. You can sort. You know, it used to be that the second semester computer programming class, you learned different sort algorithms. You learn different sort programs because depending on how your data is, then you get smart about which sort program to use. But we don't do that anymore. That's all built in. So now we build bigger and better things, and we just rely on the experts who designed the sort algorithm there. There's a sort, and depending on what you put in as the argument, or no, depending on what you're sorting, Python is going to look at the list and make a decision as to which sort algorithm to use. Okay. So that's progress. It's good because those sort algorithms were make your mind, twist up your mind. Okay, and so this will reverse an element. This will reverse a list, which is pretty cool. Yeah. No, it'll just make the zeroth element be the last element, and the second to last element be the second, second to the first. So it'll just like, flip the positions. So it doesn't reverse sort it. Although if you want, okay, so if you want to reverse sort it, first you sort it and then you reverse it, and that would reverse sort it. All right, and then you can also figure out the first item in a list that contains a particular return the index of the first item in the list that's of this value. So it doesn't appear, it removes. Here you just want to know what it is. And this is going to count the number of times X exists or X appears in the list. So if you do, you count the fives, and there's 3 of them. All right. So this tests your understanding of the different methods. Let's go down to find here. All right. This one is red, and it represents the number of integers to be read next. Okay. Read the remaining integers from input and append each integer to a raw list. Okay, so we have to raw list. This is a empty list that we've declared, and this is how many we're going to read in. And so we're going to read them in and append them to this list. Well, I can do this. I can do something like item equals their integers I'm reading, int input, and then I can raw list dot append parentheses item. Okay, that should work. I could also skip the declaration of a new variable only to use it and then not use it anymore. I could do this. I could put this directly into here if I wanted to, and then get rid of this. So either one should work. Let's try this one. Oh, didn't work. Oh, I'm looping. I got a loop. Gotta have a loop, man. A for. Um, I don't know. Uh, I in numraw. I Okay, that's what I think the problem is. Let me go to tab, I suppose. No, range. Let's see. Yeah, right. That's not, I didn't only did the, oh, yeah, I only did the first one. Okay, let's see if this works. Ah, look. Okay, so it read a number, it it iterated that number of times. Did I use this variable here, but don't need, I don't use it for anything, just to counter. Anyway, so let's do the last one. Um, I just realized something. When I skip to the last one, you guys can't go to the last one, can you? I mean, you cannot just, can you just click to three after you do one? I don't think you can. Because I think I can do it because I have like a TA version of this, but I don't think you can. So, well, that's not so bad because then you can watch it and understand it, and then when you get there, but I tell you what, I'll do this one. Uh, assuming you've done this one now, I'll do this one now. Okay. So, so we have a list and this list, two lists split with a space. And these are passengers waiting to board a bus and passengers on the bus. Add all the elements of waiting to board to the end of onboard. Remove the last element of onboard and output passenger alighted. I wonder what alighted means. Hmm. Alighted. Alighted. Excuse me, I'm just gonna. Um, get off, stepped off. He was the only passenger to alight. Oh, to get off the plane. Oh, oh. The first one. He must be the first one to get off. Oh, this one removes the last one. Okay, so we have Jen, Kai, and Abe waiting to get on the bus. So we're gonna put them on the bus. So now it's Tia, Cam, Jen, Kai, and Abe, and then we're gonna alight Abe. Abe will get off the bus. It's not that Abe couldn't get on the bus to begin with. Abe got on the bus, but then decided, ooh, there's too many people, or whatever, decided to go. So, um, that. And so then now I got to put um, onboard. Uh, oh, what am I extending? Am I extending? I think I am. I just do onboard extend, right? List extend. Okay, I just do this. List extend. And onboard extend. Parentheses. Waiting to for. Okay. And then I uh alight the last person. So I do onboard. Uh oh, alighted equals onboard um pop. Pop like a stack. No argument needed. And then I'm supposed to print um, passenger alighted. I learned a new word today. Is alighted. All right. Okay. Let's see if that is the right answer. Ah, yes. Okay. Okay. Well, you can do the last one. All right. What's the next one? Iterating over a list. Okay. Programmer accesses each element of the list. One way is a for loop, where you can say for something, this is going to be an element in list. So this loop is going to loop um, through the list. Each time my var is going to be the next element in the list or the current element in the list. So it'll start out as the first element in the list and go all the way to the last element in the list. And so that's how many times the body of statements executes. So that's pretty simple. So these are all a bunch of examples of iterating through a list and doing something or checking something. Or common error is an index error, which you're trying to refer to an index in a list that's not there. An out of range error means there is no element there. You're trying to reference the 10th element, and there is no 10th element. And then enumerate provides the iteration count. So you might be enumerating using a for list through a list, but you want to know what the actual index of it is. And so this enumerate function uh, let's see how it looks though. I don't use this at all. Um, let's see, where is an example of enumerate? Okay, it uses this. Oh, I get it. Okay, that's okay. So when you say instead of saying for token in tokens, that's what you'd normally do. And for each time you get what the token is, whatever that element of the list is. But if you also want to know what number, what position it is, then you can put two variables here and then put this here. Enumerate, and what that's going to do is going to return the position and then what's at that position. So it'll start at 0, 1, 2, 3, 4, 5, and each time it'll go up, it'll give me that. So that's what that's for. All right. These are built-in functions supporting objects. True if every element in the list is true. Hmm. True if any element is true. I guess zero is false, and anything other than zero is true. This will return an element, and this will return an element, and this will return a single value. All right. So let's try to do a challenge activity. All right, so assign this with the total extra credit received given a list of test grades. Iterate through the list with this, and then use the split method to split a string at each space into the list, at each space um, between the list values, and the map function to convert each string value to an integer. Okay. Wow, this looks like a tough one. Okay, so let's say you're given this list, and the extra credit would be anything over 100. So there'd be 1, and then there'd be 7, and so uh, you output the 8. Use the map. Hmm. Where's map? Let me see if I can find map otherwise. Oh, here's an example of map. Okay, so we're splitting an input of what is this? Oh, so it puts it down here. Okay, so this takes a list. This takes a list of strings. It's a list of strings, and we want to map each one of those elements, or each one of those strings represents an integer, and we want to, you know, uh, do that mapping. And instead of having a list of strings, we want to have a list of integers. And so that's what this does. Hmm. I wonder why you need income money. Okay, so we read user input and we end up with a list of test grades. Interesting. And then we initialize some. There's so much more space there. Okay, so anyway, so we put our solution here, and we're going to do four grade in test grades, right up there. For grade in test grades, if grade um, is greater than 100, then some extra. Oh, okay. Then uh, extra credit equals 100 minus grade. And yeah. Oh, no, it's already been done. It's already been used. Yeah. See, this takes this a string of this. It takes this string here, and okay, this is a string. This is going to split that string into four strings. One string, two strings, three strings, four strings, and then this map int is going to convert these into actual integer numbers, I guess. And somehow, I guess we need this list function here to actually make a list out of it. I don't quite understand, but I don't get that part. But anyway, so test grades is now going to be a list. And it's going to be a list of these, but they'll be numbers, I think. Okay, so this is the extra credit. And then we're going to add some extra. We're going to add EC to that extra credit. And then we're going to print it out. See if this is right. What did I do wrong? If grade is greater than 100. Oh, oh no, oops. Grade minus 100. Yeah, silly. Yeah. Okay. All right. Iterating over a list. Hmm. List raw list contains integers read from input. Representing data samples from experiment. Hmm? That's what it does. That's what it is. Okay, so we have this raw list, which we create by first we read in some tokens. I don't know, first we read in a string and then we split that into tokens. And then we loop and um, for each token we make an integer out of it and then we append it to this raw list thing here. And then we output that raw list. And then we're gonna do some passes, it looks like, and this is our loop. For each element in raw list, if the element's value is greater than or equal to 50, then okay, so I'm just gonna start this now. Okay. If each element's value is greater than 50, then increment count past and output the element's value followed by at index and then the element's index and past. Let's see. So I think I know what they're getting at. So outputs raw samples. And we're going to do for index IDX, comma, um, val for value, um, in enumerate raw list. Okay, for all them. Um, if it's greater than 50, it pass. If it's lower than 50, it's not if. a val is greater than or equal to 50, then it's passed. If val is greater than or equal to 50, then count passed equals add 1 to count passed. And what else do I do? And I output print um, val at index IDX passed. Otherwise, print val at index is flag. Okay. Okay, let's see what this does. What went wrong? Something's forgot this. Okay. Oh, well, let's do the next one because this is pretty important stuff to be able to do. So, the next one is um, this is going to contain integers read from input representing data samples from an experiment. Initialize some good with 0. Okay, initialize some good with 0 equals 0. Then for each element in samples, for I comma um, samp in enumerate samples list for all of those um, then for each element in samples list that is both at an even numbered index and greater than 55. So if I mod 2 is 0 and samp is greater than 55, if those two things are true, then um, output, then print uh, index, comma, I, um, colon, I'm gonna have to mess with this because there's gonna be a space in between the I and the colon. I don't want there to be, but I'm gonna first do this, colon, comma, element's value is SAM. And increase some good by each. Oh, each such element's value. Okay, so that means each value that passed. Some good. Add on to that SAM. Okay. Now the problem is that this index thing is wrong, and so I got to use that F thing. And let me just go back and refresh my memory on that. It looks something like this, doesn't it? Goes to show you how lazy I am. So I'm going to instead replace it with something like that. And the sum is going to be index colon index uh, index space um, dent dent colon SAMP SAMP. So this is what. Get rid of this. This should be the right print statement. So this is not even, oh, this is 0. Okay, so 0, 1, 2, 3, 4. Even numbered index. I guess 0 is an even number. So 57 plus 56 is 56 plus 0. 0, 1, 2, 3, 4. Okay. What am I doing? Oh, it's got to be greater than, it's got to be greater than 55. I was thinking it has to be greater than 50. Okay, so is that right? Yeah, 55, greater than 55. Okay, so it's going to be this one and none of the other ones. Right? Not this one because it's not at an even number. So yeah, 56 plus 57 is 113. Okay, so index 0 and index 2. Okay, so let's see if this is right. Ah, good. Very good. Okay, so you can do the last one. Okay, list games. Yeah, I'll close this one. Okay, you can look at list games. Let's look at list nesting. Nesting list. Okay, you can play these games. Fun games. List nesting. All right. Since a list can contain any type of object as an element, any type of object, it can also contain an element can be a list. So you can have a list of lists. And here we have a single list. This list has two elements, and they're both lists. First element is a list that also has two elements, and the second element is a list that has three elements. Okay, so so that's list nesting. It's like you'd think. Okay, so all right, let's try this one. We've got these lists here. This one, this one, this one, this one, four lists, 1, 2, 3, 4. And then we're gonna assign all spellings with a two-dimensional list consisting of Oh, so we're gonna assign this to be this, and we're gonna assign this to be this. But I think we're gonna do it by appending. Okay, let's do it by appending. See if that works. So we're gonna um, we're gonna append a list onto a list. We aren't gonna extend a list by a list. We're gonna append a list onto a list. So first, let's declare. First, let's declare a list called all spellings. Okay. And then we're gonna all spellings dot append parentheses spelling one, and then we're gonna do this 3 more times. This is a 2, this is a 3, this is a 4. Okay. Mm-hmm. Yeah. All right, let's see what you got. How do I declare a list? Is it this? That language. That's how you declare a list, right? Yeah, that's how I'm sure that's how you declare a list. You got to do that. So you do it in every language. Okay, so let's do the next one. A two-dimensional list game board consists of a 3x3 tic-tac-toe game board. Read from input, the list the game contains 3 lists. Okay, blah, 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 blah. Okay, so um, if all elements at a column index 2. All right, so we're reading in 3 lists, and we're supposed to test if all of the elements at column 2 are O, then output A wins. At column 2. Otherwise, no win at column 2. All right. Okay, well, here we've defined a. All right, so we have game boards, 3 lists. Okay, so we want to look at um, if um, game board um, this is the row. Just how do you refer to, how do we refer to? That's what I thought. Okay, so yeah, right. Oh, oh yeah, got it. Okay, I wasn't. Okay, so then we do it this way. Yeah, this way. 0, um, 2 equals O, and So this is if row zero, uh, column two is an O, and row one, column two is an O, and row two, column two is an O, then print um, a win at column two. Print a win at column two. Guess. Well, what if there's X's? So I don't know. This is kind of funny. Got the All right. If that's equal to an O and that's equal to an O and this is equal to an O, then print a win at column two, otherwise no win at column two. I don't know if this is what they're looking for. This must be what they're looking for. Okay, this probably just goes on. I won't do this one, but hmm. Okay, so in this one we are going to read in some number of lines, and we've declared an array. And here we're going to read in, for, we're going to create an array of rows. No, we're going to create um, another array, which is going to be called row elements. And we're going to read in, so there's going to be three of them. We're going to read this in. We are going to we're going to split this into a list, and then we're going to why do we do this? Okay, we're going to split it into a list, and we're going to stick it into this array. And then what? We're going to output each row like that. Okay, so then we're going to loop, and we're going to output each row um, by joining the elements back into a list using a hyphen as a separator. So gee whiz, can I just do this? I'm just going to do this. Um, print um, this dot join row elements. I'm going to see what that does. Um, Item 0. Expected a string instance. Um, maybe these have to be strings that are joined together. And so, uh, do I need to string back? I don't think I need to. Okay, I'm going to do this instead. Print F colon. Inside here, I'm going to put, no, that's not going to work either. Okay, I guess I have to do a loop. Unless I use the map, I do that. I want to map them back into strings again. What time is it? Oh, it's way past. All right, I'm going to try to do this. Map list. Okay, right here, I've got inside this, I've just appended this row of elements on, and oh, I can't put anything in there, can I? I need to convert this back into, okay, this is, I'm trying to think of how far, okay, this is 8.5. How far back did we learn about maps? So that was down here. Is that in this one? Oh, maybe it was this one. Okay. Um, so this took a list of integers and made it into strings. So can I do this to convert it back into strings? I don't see. Um, so how about if I go something like just do list equals list map, and I'm going to make this be a string, and I'm going to do row elements here. And okay, let's see. Now what happens if I print string? Uh, now I'm going to try this. And if this doesn't work, I'm gonna quit and figure it out and tell you the answer next time. See what this looks like. Oops, darn. See what it look like. That's pretty close. That's pretty close. So wait, did I get it right? Oh, I got it right. Ooh. Huh. Well, what do you know? Okay, so yeah, so see what I did was this is my new code. I took this is a list of element of integers, and to be able to join, you got to join strings. So I need to convert that list of integers back to strings. And so that's what this did. I used this fancy map thing and created a list there, and then so that's okay. Anyway, all right. So uh, I've taken you through section 8.5. I'll do some catch up. Next week it's going to be the other professor that's normally um, who is listed in the course catalog to be in the schedule to be teaching this course, but I'll still be around, still be available by email. So will he. If there's anything you don't understand or something that you didn't understand with him or with me or whatever, just email either one of us. All right. Do you have any questions? All right. Thanks for watching.